Hello. Is it audible, right? Hello. పెట్టాను కానీ అన్లిస్టెడ్లో పెట్టా. పబ్లిక్ పెట్టేసాను, ఎవరు చూస్తలేరు కదా. పబ్లిక్ పెట్టేసాను. Right. Hello. So the last class we were preparing that alcohols. So that alcohols topics we will do today. Right. How can we prepare from alcohols from aldehydes and ketones? From carboxylic acids by reduction. Right. Yeah. Yeah. So preparation from carbonyl compounds. No? So generally, for example, if we can take the aldehyde, right, on oxidation we'll get carboxylic acid, right? So on reduction we'll get alcohols. Alcohols further reduction will get alkanes. Okay, alkanes, oxidation. So like this is the total process. So alkanes, alcohols, aldehydes and ketones, and carboxylic acids. So carboxylic acids on reduction will get aldehydes or ketones, depends on, obviously the aldehydes will get. So then further reduction will get alcohols. Alcohols on reduction will get alkanes. Write it down. Done? So this is the general pattern, right? So depends on the reagents, we are keep on changing, of course. Right. Preparation from alcohols, we can aldehydes, ketones, and carboxylic acids. Put the heading. So preparation of alcohols from aldehydes, ketones, and carboxylic acids. Aldehydes, ketones, and carboxylic acids. Done? Right. So for example, from aldehydes, hydrogen in presence of nickel, platinum, or palladium, will get alcohol. Otherwise, we can use sodium borohydride or lithium aluminum hydride also. The reducing reagents we can use. So write these two reagents now. వర్షం వస్తుందా? Right, so sodium borohydride and lithium aluminum hydride. Right. In case of ketones also same. Write it down. Ketones, hydrogen, nickel, palladium, platinum. So aldehydes will give the primary alcohols. Ketones will give secondary alcohols. NaBH4 or lithium aluminum hydride. So the above no need to write. Just directly write the equation. So. Hello, yes, sir. No, no. I just class is going on. If possible, let her join in the yeah. Done? No? Yes, sir. So when carboxylic acids, when we are using the lithium aluminum hydride, so write it down. Carboxylic acid with lithium aluminum hydride, we will get alcohols. Done. And most important point here, carboxylic acid cannot be reduced to alcohols by catalytic hydrogen. Hydrogen in presence of nickel, platinum, palladium. This point is very important. Write it down. And two important points which we can write over here. Hello. So one is with NaBH4. NaBH4, because aldehydes, ketones we did with NaBH4, but in case of carboxylic acids, so NaBH4 as well as catalytic hydrogenation. Catalytic hydrogenation means hydrogen, nickel, platinum, palladium. So it can't be reduced. So important points, no? Very, very important.
ఇందాక పాయింట్లో నికెల్, palladium, platinum.
This is, what is this?
Carboxylic acid.
Earlier. No. Ketone, right? Ketone. So first case aldehyde, then second ketone, right? Then carboxylic acid. So in case of ketones, it is sodium borohydride and hydrogen in presence of nickel, platinum. Aldehydes, ketones will give, but not carboxylic acids. This is the important point which we need to write. So write so put in 5 stars and write it down. Okay. Right, sorry, actually. So now is it audible? Yeah. So carboxylic acids can't reduce with the, right, NaBH4. Right, NaBH4 as well as hydrogen in presence of nickel, platinum, palladium, those catalytic hydrogenation. Catalytic hydrogenation. So because this NaBH4 is weak reducing agent, Nana, when we compare with the, right, lithium aluminum hydride. So here is from carboxylic acids, alcohol will get ester. Esters on reduction will get mixture of alcohols basically. So do one thing. This is esterification. Put the heading, one of the important reaction. Esterification reaction. Esterification reaction. Esterification means preparation of ester. R C double bond O, OR. So we are preparing the esters from carboxylic acids. Particularly, they are asking the questions here. When we are taking the carboxylic acid, R C double bond O, OH, okay, plus we take the alcohol, OH, R. So it's a equilibrium reaction. Generally, we could say. What exactly happens? The reaction takes place like this. The OH group from carboxylic acid and right, from alcohol H. What exactly will get? R C double bond O, right, OR. Ester is forming. Ester. So write this important reaction here. R C double bond O, OH, right, R C double bond O, OH. In this case, Nana, this is won't happening. So means H from here, OH. So write exactly this is not forming. That means OH group from the alcohol we can't take. So they keep on asking the question this particular area. Okay. For example, CH3 C double bond O, OH is a 18. Oxygen, I am just writing the isotope 18. plus OHCH3. So now they are giving the options here. Option A, CH3, C double bond O, OH, it is the 18 plus water. This is option 1. And option B, CH3, C double bond O, OH plus H2O, it is the 18. Now let me know which one is correct, option A or B, right? Option B is correct. Option B is correct because the OH water is going like this, right? The water is going like this, the 18 will come in the water. So very, very, very important. Put 5 star on. Sir, why only it's going like this, right? So based on mechanism, we observed that. Okay. So they did the experiment. We had the mechanism. Now, in the esters, if the esters are a reduction, right? So we'll get 2 moles of alcohols, like mixture of alcohols will get RCH2OH plus, that is also converting into alcohol, ROH. So mixture of alcohols will get by the esters on reduction. So first in the esterification, carboxylic acids, alcohol, first learn this. So one of the important, and this is the area which we need to. And one more important thing, they are keep on asking which alcohol. It is alcohols. Hello. CH3, CH2OH, primary alcohols are more than secondary alcohols. Secondary alcohols are more reactive than the tertiary alcohols. Tertiary alcohols. Okay, so write it down. Because the acidic nature, in this case we can understand the reaction is because of acidic nature of alcohol. Which alcohol is more acidic, that is more reactive. So how should we know the which is more acidic? Based on inductive effect. Based on inductive effect. The people who don't know the inductive effect, so I'll explain for them later. So based on inductive effect, so this is more reactive in the esterification reaction than secondary alcohols and tertiary alcohols. Simply primary alcohols, then secondary, then tertiary reactivity of alcohols. And more important thing is, if the carboxylic acid bulkiness increasing, the reactivity order also is decreasing, but they are not asking much about the carboxylic acids. This is more than enough. Just write it down first. Done? Right. So here is carboxylic acids. When alcohol will get the ester, ester on reduction, mixture of alcohols we will get like this, RCOOH. So we'll get the mixture of alcohols. Right, write it down. So here you may get one doubt. So the doubt was reduced here. So here is lithium aluminum hydride is a expensive chemical. So whenever we are preparing one particular product, it should be easily available as well as cheaper, right? Adi easyga available undala, cheap undala. Then only, right? So we are using here is a, because lithium aluminum hydride is somewhat expensively, right? So that's the reason. So first carboxylic acid and alcohol will get the ester, on reduction will get mixture of alcohols. Like that they are preparing. The cheaper method we are using, right? So you may get, right, sir, lithium aluminum hydride we can use, right? From carboxylic acids directly we'll get alcohol, of course. Yes or no? From carboxylic acids, if we are using the lithium aluminum hydride, I already gave you in the previous right here. Right? In this case, directly we can prepare the alcohol. So why we are converting into esters? Then why we are doing means because lithium aluminum hydride is somewhat expensive chemical. Got it? So if you want, you can take the screenshot. If you don't want to write because you people are lazy, I know. Then same thing, of course. Alcohols will get ester, then reduction. Of course, I already gave you, right? And this type of questions also they are asking the fractional distillation. In case of Riemann-Tiemann reaction, coal-based reactions, if they are boiling points, based on if the closer boiling points, then they can separate it by the fractional distillation, right? If the mixture of alcohols are obtained as a closer boiling points, then what we can separate by the fractional distillation. What is fractional distillation? Distillation means when two components are there, when we are boiling it, right? When we are in a heating, so automatically based on boiling points, this evaporation takes place. So, right, this example, already we discussed this. Here is the OH group is in the bracket, but H plus only is going out. Okay, don't confuse here in this particular case. H plus is only going, but here they didn't give us, just the process example. Done now. Right, already we discussed all this. So ketones, aldehydes, carboxylic acids, mainly carboxylic acids, I told you, we can't use this lithium aluminum hydride as well as hydrogen in presence of nickel platinum. So if you want to write it all one place, you can write it down. This reduction. Summarized below. So aldehydes, ketones, of course we are using the same reagents, whereas in case of carboxylic acids, the special thing is just keep in your mind. Hmm. Right, so here is lithium aluminum hydride and NaBH4. Just write a table here. So how we will get the alcohols, this is important thing. So here is lithium aluminum hydride is stronger reducing agent. So whereas NaBH4 is a weak reducing agent. So for example, if I am taking aldehyde, so when we are using the aldehyde to, right, what we will get? Alcohol, right? Aldehyde to alcohol. So we can use lithium aluminum hydride as well as sodium borohydride. Right? For example, if you can take ketone, you get a secondary alcohols reduction reaction. So we can use lithium aluminum hydride as well as NaBH4. So write it down. For example, acid chlorides or C double bond O Cl to alcohols. Acid chlorides, right? So both are giving none. But the ER answer is important. If you take the ester or C double bond O or ester to alcohol, right? Lithium aluminum hydride is giving, but not NaBH4. Okay, write it down. Lithium aluminum hydride is giving, but not. If you take carboxylic acids, RC double bond OH, right, to alcohol, RCH2OH. Now let me know in case of carboxylic acids. So lithium aluminum hydride will give, but not NaBH4. So not only carboxylic acids, even ester also. Write it down. If you take anhydride, RC double bond O, C double bond O, or to alcohols, lithium aluminum hydride. So write that one. Anhydride. So this lithium aluminum hydride not only here, so to preparation of amines also will use. So first complete this. So for example, cyanides generally is converting after reduction RCH to NH2, right? So even for example, if you can take amide RC double bond O NH2. So this coming is later, but lithium aluminum hydride how we are using, okay? RCH2 NH2. For example, R CH2NO2, right, or CH2NH2. So write it down. Here is lithium aluminum hydride, NaBH4, sodium borohydride, so lithium aluminum hydride reduces cyanates to amines, amides to amines, nitro compounds to amines. Come on, write it down. Or CH2N3 or CH2NH2. So whenever the lithium aluminum hydride and NaBH4 it's coming, so you should have the clarity. If you are taking the isocyanates or NC, so when isocyanates on reduction, we'll get secondary amines. So here also, this is the pattern which is follows. Right. So here is one important question which I'm going to tell you right now. So basically, lithium aluminum hydride is giving simply H minus, right? H minus. Aldehydes and ketones generally we know nucleophilic addition reaction, right? For example, aldehyde, so H minus is acts as a nucleophile. So nucleophilic addition reaction is takes place, H minus is coming and attacking over here, right? So what we will get? R C O minus H H. So then afterwards we'll do the hydrolysis. H2O, the H plus is coming and attacking over there. ROH HH. So this is a basic mechanism. Now they are not asking the basic mechanism. So they are asking the different question. I'll give the question that. So first write this mechanism. Especially they are asking the question which I'm going to give you right now. The type of question they are asking. Then now, so they are asking the based on this. So write a question. D2O. So after hydrolysis, I am writing the D2O, and here I am giving lithium aluminum D4 and H2O. This is option A, and in this case option B we will get. Right. So I am just giving the options here. Right. Option A, This is A. This is A. This is B. Option A, B. So match the following like that. So two options only I am giving you to avoid the confusion, right? Two options only giving, so because they'll give the 3-4 options, of course. Particularly try to understand, right? Here is what is the answer. So in this case, H minus is coming, right? Lithium aluminum hydride. The first case, H minus is coming and attacking over here, so it goes up. So what exactly we'll get? Here is the H, O minus, then what? D2O is coming, right? So D is coming over here. OD. This is option A is the. In case of option B, because sometimes we need to know the mechanism, that mechanism, this type of cases they are asking the question. In case of second case, hello, D minus is coming and attacking, right? D minus is here. So what we will get? O minus, here is D, then water H2O is I gave you OH and D. OH and D, obviously what is the answer? Answer, second one is right. Is Vera. Clear? Don't confuse. If you have any doubts, please let me know. You can see this mechanism. This is for B. This is for A. Write it down. Write it down. Then, so one more important couple of questions which I am giving you right now. So write it down. We can use C double bond O, NO2, lithium aluminum hydride, NaBH4. Come on, write the answer. The question number 1, very important. This type of questions they are frequently asking. Come on, do it already. Answers with you. Come on, write the answers. Done? Completed? Hello? Right now, Rasara? Hello? Yeah, first case now. This is converting into alcohol. This is also converting into NH2. Whereas down one, this one wrong. So down one, NO2 will be NO2 only. In this case, so both are lithium aluminum hydride will reduce alcohols as well as ester. So particularly here is OH. So don't confuse the number 1, 2, 3, 4, 5, 6. OH plus ETOH also is coming. Whereas in this case, now lithium aluminum hydride, OH and ester is same like ester only, ET. So here is alcohols are coming, esters on reduction, right? In this case, completed that here. Lithium aluminum hydride, OH, and it is converting into, here is OH, right? This is also OH. Two OH are forming. In this case, this is OH, but remaining this is as it is. Got it? Anybody confusing, please let me know. The last one is important. Of course, here lithium aluminum hydride cases all are converting into alcohols. So just write it down. I'll go down and I'll write. Ester, RC double bond O, OR, right? So what exactly happens here? RCH2 OH or OH. రెండు ఆల్కహాల్స్ వస్తాయి కదా. That is ester. So we are breaking here. So one is converting to OH, one OH over here and one OH over here. Okay. So this type of, I mean, people confuse, right? You know all the reactions, but done. The last one. Yeah, last one, no? Lithium aluminum hydride. So this is OH, this is CH2OH, and here is, right, here is OH plus ETOH. This is what? When you are using the lithium aluminum hydride, right? If you are using sodium borohydride, let me know. Sodium borohydride. Here is the OH, okay, right? OH, of course. Here is ester is same like ester. It won't change. Sodium borohydride. NaBH4. So very, very important. NaBH4 and lithium aluminum hydride. So n number of people are confusing this type of questions. They keep on asking. Couple of questions at a time they are giving. So sometimes in the mechanism wise also they'll ask the questions. Right? Come on, note it down. అరే నీకు ఎట్లయితే ఇప్పుడు ఇక్కడ ఇక్కడ అయిందనుకో ఒకటి వెళ్ళిపోద్ది కదా ఎస్టర్ వాటర్ ఏమి వెళ్ళిపోతుంది రెండు రెడ్యూస్ అవుతాయి కదరా OH OH ఒకే కార్బన్ పైన ఉంటే వెళ్ళిపోతుంది రెండు కార్బన్స్ కదా వేరే వేరే ఒకే కార్బన్ పైన ఉన్నప్పుడు బై డిఫాల్ట్ అవే వెళ్ళిపోతాయి డన్ అన్న yes so this is one level so which I gave you the another level so because sometimes so here combination of all carboxylic acids ester also if the lithium aluminum hydride is coming so it's confusing us so that is the reason I gave you at one place okay hello and of course preparation from Grignard reagent. So last class I discussed this Grignard reagent, right? Hello. Make this kind of like apply the sir fast repairs. RMGX with alcohol only. I am just explaining. RMGX. R means alkyl and magnesium. This is OMC. Organometallic compound, not OMG. Oh my God, right? OMC seems to be like that only. Mirror. దీని జీ లాగా రాసుకోకండి ఎవడరా మీకు ఓఎంజీ ఇట్లా రాపించిన అంటున్నా రైట్ ఆర్గానోమెటాలిక్ కాంపౌండ్ అంటే ఏంటి వాట్ ఈస్ ఆర్గానిక్ మెటాలిక్ కాంపౌండ్ ఆర్ మైనస్ ఫర్ ఎగ్జాంపుల్ ఎల్ఐ ప్లస్ రా సో ఆర్ మైనస్ ఎంజీఎక్స్ ప్లస్ లైక్ దట్ సో here is X ra X generally will take right chlorine or bromine or iodine. R means we know alkyl group methyl, ethyl, propyl. So magnesium. So how we will prepare this RX plus magnesium in terms of right ether, diethyl ether. Directly you can write ether. We'll get RMGX. This is Grignard reagent. The formation of Grignard reagent. Ri is right, then RBr. Then RCl, right? So means from alkyl iodide we can easily prepare the Grignard reagent, then the RBr, then RCl. Just write it down the preparation this. Right. So particularly if I am taking the formaldehyde, when aldehydes ketones undergoes, I told you which type of reactions? Nucleophilic addition reactions, right? So nucleophilic addition reactions R minus mgx plus, directly I am taking the R minus nucleophilic addition reaction. What we will get? H CO minus H, of course R, then here is mgx mgbr plus, if I am giving you, so mgbr plus here. After hydrolysis, right, H OH H R, nothing but what? RCH2 OH nano. So if you are taking the formaldehyde, particularly formaldehyde, will get primary alcohol. Primary alcohol. If you are taking the formaldehyde, primary alcohol, write it down. No. So directly write it down. This is formaldehyde with RMGX. After hydrolysis, will get primary alcohol. So if you take any aldehyde except formaldehyde, any aldehyde with RMGX will get secondary alcohol. So if we take ketone with RMGX, water will get tertiary alcohol. So write it down. This is very, very important. You can prepare. No. So now secondary one, just write it down. We take any aldehyde, same reaction, RMGX. What we will get? R minus is coming and attacking over here. R CO minus, here is the R H MgX after doing the hydrolysis. OH R, no, secondary alcohols will get. But already we know. If you take the ketone, same as it is. we will get tertiary alcohol. Right? Done? So the same of course, ketones will get tertiary alcohols. Water means obviously the nucleophile in the given addition reaction. Which one, Anna? H2O. A lot of people are confusing is the OH minus, but H2O is the nucleophile. Major product, of course, here is the OH is coming. Option B is the correct one. A, B, C, D. So this in electrophilic addition reactions, of course, I explained. Obviously, H3, which one? B2, H6, NaOH. Primary alcohol, hydroboration. Last class I explained. Hydroboration. This is. So hydroboration, the people who didn't come yesterday, just write it down. This is very important. For example, CH3, CH double bond, CH2. If I am adding the H2O in presence of H plus, the major product I am writing here. Major product is CH3, CHOH, CH3. If you are doing the hydroboration, BH3 in presence of THF tetrahydrofuran, H2O2 in presence of OH minus, we will get this is the major product. Primary alcohol will be the major product. Come on, write it down. This is hydroboration. Hydroboration. Done. This is the reaction. Which of the following is product is not possible in the dehydration of the products? Come on. Which is not possible? Which is not possible? Hmm? Hello? First, the OH is going out. Iris will get the carbocation, right? Here we'll get the carbocation, right? Here, if it is this hydrogen is no, so this one is the major product because more number of alpha hydrogens. Of course, D is the which one? Sorry, B, C is the major product because we'll get number of right carbocation. Removing over here, number of alpha hydrogens. Cross check it. Number of alpha hydrogens. In this case, 3. Here is 3, and here is 1. Total will get 7. Whereas in this case, here is case 2, 2, 3, 2, 5, 7, 9. In this case, 1, 2, 3. But the problem is how it is coming here. The carbocation, it is not moving here. Why it is not moving? Huh? Here is the carbocation. So, if the carbocation is moving here, so cross check 3, 2, 1. How many alpha hydrogens? In this case, 6. No. Whereas here, 2, 2, 1, 5. So stability is decreasing here when we are coming here. So means it won't form. Got it? This one won't form. It is not the product. So this is a carbocation, tertiary carbocation, of course. Right. So what exactly happened? B cannot be formed by the dehydration. Which one? This. Got it? This is won't form. అర్థమైందా నేను చెప్తున్నాను? Hello. Carbocation stability we need to cross check in the dehydration. So what exactly happens in the dehydration? First CH3, CH2OH. For example, first H plus is coming and attacking over here, which where CH3, CH2, OH2 plus. Then what exactly happens? Second step, water is going out. When water is going out, what we will get? CH3, CH2, carbocation. So then afterwards adjacent hydrogen is going out, we'll get the alkene. Actually this is the mechanism. So where in this case carbocation is coming, so the carbocation stability is important for us. Write it down. So now try this. So first protonation is takes place, right? Protonation is takes place CH3, CH, OH2 plus, CH2, CH3. So then what exactly happens? Water is going out. So then this is important here. CH3, CH plus CHH CH3. Now CH2H. Next step, which hydrogen we need to remove?
Right.
This is green or yellow? Yellow. So if we are removing the green hydrogen, we'll get this compound CH2 double bond CH, CH2 CH3. If you are removing this green hydrogen, okay, H plus is, if it is yellow, CH3 CH double bond CH CH3. Which alkene is more stable? That is major product, right? This is major one. Why it is major? Because number of alpha hydrogens we need to cross check. Double bond adjacent carbons, this is right 3 3. This 6 alpha hydrogens. More number of alpha hydrogen alkene is more stable. In this case only 2 alpha hydrogens. 2 alpha hydrogens, so that's the reason. So we need to remove this hydrogen. So write it down. అర్థమైందా? So we need to know the alkene stability. Alkene stability, how should we know? Alpha hydrogen, CH2 double bond CH2. This is one type of alkene. CH3CH double bond CH2. CH3CH double bond CH CH3. CH3 double bond CH CH3. Right, in this all these alkenes, which alkene is more stable? A, B, C, D. Which alkene is more stable? Right? Which is having the more number of alpha hydrogen, that alkene is more stable. So here this is a double bond adjacent carbon ray. This carbon we could say the alpha. This is alpha carbon. It is having how many number of alpha hydrogens? 3. It is 3. Here is 0. We didn't have any alpha hydrogens. In this case 3 plus 3, 6. This is 3, 3, 3, 9. Like that we need to cross check. So more number of alpha hydrogen compound is more stable. The people who don't know, please write it down. The people already you know, so no need. Then completed. So this type of questions they keep on asking based on this. Which alkene is more stable? Let me know. Write the stability order, which is come on, write the stability of alkene. Stability of alkene. Which alkene is more stable? Right. So while finding out the alkene stability, so we need to find out the alpha hydrogen. alpha hydro, number of alpha hydrogens. Double bond carbon, these two, right? Adjacent one. This is alpha, this is alpha, this is alpha, this is alpha. So now we need to write the number of alpha hydrogen. Already carbon, only one single bond is there. Carbon is always having the 4 bonds. Already one bond is there, means how many hydrogens here? 3 hydrogens we need to put. In this case also 3 hydrogens. It is 2 bonds already there, so means 2 hydrogens. 2 hydrogens. If you are confusing, so you can write like this: C double bond C, 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 like this, C, C. So this carbon is having only one single bond, means we have to write 3 hydrogens. Here is 3 hydrogens. Here is CH2, CH2. Total how many? 10. 3, 3, 6, 7, 8, 9, 10. 10 alpha hydrogens. This is alpha carbon. This is alpha carbon. 3, 1. 3 plus 1, 4. 3 plus 1, 4. This is carbon, carbon, this is carbon. 2, 2, 1. 2 plus 2 plus 1, 5. 5. This is alpha. This is alpha. यहाँ पे 1, 2, 3. So now 10 greater 10, then 5, then 4, then 3. Simple. So A, C, B, D. A, C, B, D is the answer. Come on, write it down. If you have any doubt, you can ask me. Done. Same type of question. Let me know the order. Come on. Easy question. Is public bit. ఇప్పటి నుంచి వస్తుందా మొత్తం వస్తున్నది వస్తుంది. వాట్ ఈస్ ఆన్సర్ రా? Here is 1, only 1 alpha. Here this is alpha, alpha, alpha. 3, 3, 3, right? 9 raw. Here is this is alpha, this is alpha, this is 3, this is 2, 5. This is alpha, this is alpha, 3, 2, right? Of course both are same. Both are same, right? So just even both structures also same. So of course you can neglect this one. Hey, hey. Nice shot. So what is the answer now? BCA. So BCA is the answer. BCA. Right? So remaining things will continue tomorrow, Nana. So the alcohol only will continue tomorrow. Chalo.